Hello everyone, this is Vinita, studying in 8th SEM ECE from Sri Venkateshwara College of Engineering. Today my topic will be investigation on effect of applying different structures on OLED devices to its performance and quality. Moving on to next slide. Today we'll be discussing about the introduction, literature review, methodology, results, conclusion, and references. Moving on to introduction, OLED devices, like it has a popular technology for displaying and lighting application due to their high efficiency, low power consumption, and color reproduction. So we'll be discussing how to improvise these factors and to give a betterment in the devices. The devices consist of different layers, that is organic and inorganic thick layers, which uses some electron and hole transport materials for incorporation and injection layers. Like it will also analyze the resulting performance metrics such as luminance, efficiency, color, and also for betterment in understanding how modification can be done to overall quality and performance wise. The main aim of this topic is to provide how to achieve superior performance and quality for lightning applications and to advance the developing OLED technology and to enable more efficient and high quality OLED devices. Moving on to basic structure, it has cathode and anode. Then the layers, there are transport layer, that is whole transport layer, electron transport layer, emissive layer, and electron injection layer. When the voltage is applied to OLED devices or OLED structure, electrons are injected from cathode into a transport layer, that is electron transport layer, and holes are injected from anode into hole transport layer. A multi-layer structure consists of 8 layers, which is substrate, anode, cathode, electron layer, whole layer, and emissive layer. Moving on to objectives. The objectives of OLED are to improve the overall efficiency of the device, to enhance the durability, to improve the color production, brightness and ability to produce more bright colors, colorful display, and to reduce the cost of the OLED devices, to explore new applications for lightning and sensing technologies, and to improvise on new applications which will benefit the unique properties of OLED devices. Moving on to literature review. Literature will be first paper is impact on different structures of OLED devices by Shubham. The pros of this paper is to useful developing high performance, and the cons are it cannot be generalized for other materials. It's only for specific structures and specific layers in the devices. And the second paper is in enhance efficiency of OLED by control laser imaging condition by Shang-He in 2012. The method will be for enhancing the imaging of technology by lasering and to give the practical performance of high performance of OLED devices. And the cons will be focusing on the OLED performance and to achieve more like it does not focus on other properties, it only focuses on the performance. And the third paper is an experimental study of the different multi-layer OLED materials processed by slot die coating by Roop in 2016. The pros of this paper is to process the OLED fan manufacturing and to improves the efficiency of the OLED production. And cons is it does not suit for multi-layer and it will not process by slot dyeing coating, and it does not explore other processing properties. Next is methodology. We'll be discussing the methodology of this topic. The first step is to research at objectives, and the second one is to review the investigation and how the betterment can be. We can improvise the topic. And the third step is to design and fabricate OLED devices and to just know about the specifications and a layer thickness and have the composition and allow the composition of the material. And fourth step is to electrically and optically properties are fabricated, which involves in measuring the stability, efficiency, lifetime using the standard testing protocols. And it will also have the comparison between different structures. And fifth step is to introduce the different structures into OLED devices. And the sixth step is to have the effects which will reveal the different structures on OLED devices and quality. And the seventh step is to improvise the device performance and quality. And the final step is to validate and see the results. Block diagram consists of anode, which is a electrode made up of indium tin oxide, which allows the light to pass through it. And the next one is a whole layer, that is whole transport layer, which will have the positive charge from anode to emissive layer. And next one is emissive layer, which will have the flow of electric current through the device, which is useful in efficiency, which will to get the desired color. Emissive layer is used. Next is transport layer, that is the electron transport layer, which is negatively charged from electrons from cathode to emissive layer. And cathode, it is a reflective or a semi-reflective electrode made of for materials such as low work um, function, like calcium and aluminum. It will reflect back. An encapsulation layer is a protective layer which prevents the device from damage, moisture, sun, and other environmental issues. Next is flow of the flow diagram. So we'll be in this flow diagram, we'll be knowing the flow of the topic. First step is design, second is fabrication, then encapsulation, assembly, testing, integration. We'll be just knowing the importance of these steps to know better on the topic. First is design. We design a OLED device depending on the development and selecting the material and layers for application. Next is fabrication. Once design is complete, the OLED device is fabricated using various techniques such as vacuum decomposition, etc. Then encapsulation. After fabrication, OLED device is encapsulated to protect moisture and from oxygen and from other environmental issues. Second is then fourth step is assembly. The encapsulated OLED is assembled into final product, which involves in lightning mixture and also improvise the device in integrating it. Next is testing. The assembled OLED product is tested for its performance and reliability. The testing includes current voltage and luminance voltage, extra integration. Once the OLED device is tested and passed through it, it is integrated into large systems such as television, lightning networks. Next is results. Basically, this topic deals about the improvement and bettermize how to use efficiently and betterly the OLED devices and to have high quality and performance. So these in this topic we discussed about having different structures and different layers, which will improve the color property and leading in more accurate color in OLED devices, and have the simplified manufacturing process and resulting in low power consumption and low power cost of the device. And we'll have the certain substrate which will identify the combination of substrate and layers structures and result in betterment of performance, and which will have the wide range and have the unique property and development in the OLED technologies, and have the more efficient, stable, and cost effective OLED products for wide range. These are the display qualities, which will have the red light and blue light depending on the wavelength. Red light will have the wavelength of 600 to 650 nanometer, and blue light will have some 440 to 470 nanometer, and the both intensity will be from 40 to 50-40 to 80%. Applications are they are used in OLED display technology, lighting, automotive displays, medical devices, industrial applications. Conclusion. By combining the computational modeling, fabrication, characterization, and analyzation, it is possible to identify new devices, structures, and fabricating methods that can improvise and efficiency wise and brightness wise and lifetime wise. The resulting of different devices structures have shown in the improvement of the stability and efficiency and spectral properties. However, it can have the trade-off of lightning, highlighting the performance of balancing different designs. Overall, it has an approach of designing and optimizing OLED devices for specific specifications. With ongoing research and development, it also helpful for further improvement in OLED performance and quality, which will be achieved, leading new like innovative applications for existing technologies. So basically, it just improvises the OLED device's performance and quality and luminance effect stability, and to correcting the color function and betterment of the color function. Uh, these are the references reviewed for this topic. Thank you for the opportunity. Thank you.